Alright, so we're gonna solve the fourth problem in our arrays and hashing. It's a group anagram. It's similar to valid anagram. So let's look into the problem. So we have array of strings. We need to group the anagrams together, and you can return the answer in any order. So what is anagram? It's a word or a phrase formed by rearranging the letters of a different word by a phrase of a different word or a phrase, typically using all original letters. So basically anagram is, for example, this one is eat. We need to have, if we have two different words, they must have the same count of letters in each word. For example, we have E here and we have E here. We have A here and we have A here, and we have T here and we have T. And that's basically what we have here and what we have here. There is no more or less. That's an anagram. If the same letters and count of those letters are the same as another string, then they are anagram, otherwise it's false. So basically that's what's an anagram. We have this input and we need to group them together to find the common anagram, and based on this common anagram we're gonna return the list of that common anagram. So we have like three groups here, this group and this group and this group, and if you have noticed, like this one is the same anagram signature as this one, and this is the same anagram signature as this one. So they are all the same signature. We have this 10 like TAN, we have TAN, so they are the same signature. So we have some kind of key here, which is the signature of anagram. So how can we solve this problem? The constraint, by the way, it's like we don't have zero length, so we're starting at 1. So we always make sure we have at least 1, and the size of length can be empty. The size of string, I mean, any single string can be empty. And by the way, it always consists of lowercase English. So how can we solve this problem? So since we're gonna use some kind of key here, which is our anagram, so I could probably think of map. So let's begin our thought process. So we can iterate through this kind of stuff, array of strings, and find the signature. And if we find anagram signature, we're just gonna compare our signature to other what we call it, like to other strings. And if we find that the other string has the same signature as our previous signature, then we just append the new string to the value of the list. So we need to have a key as a signature, an anagram signature, and we need to value as a list of string. So let's start by doing this. So we need to have a map. This map is gonna be our anagram signature, and anagram signature in our case should be like array of 26 char. But if we're gonna just use integer here, then it wouldn't really be beneficial due to the fact that if we try to compare reference types, it would generate, or not generate, it would compare two reference types different, so we will have false value while we should expect a true value. So I'm just gonna change this to string instead of array of integer, and for the value it's gonna be list of string. Alright, so now I have created my hash map, and I also may need to define the results, which we're gonna need to return, and we're gonna return the result at the end. Alright, so now we need to iterate through our array list. Not array list, array of strings. So now we have our string here. What should we do here? So we need to have the anagram signature for this one. So we're gonna make short array, and we need to define our anagram signature anagram, which is gonna be of size 26, since we have a constraint of lowercase English letters, so basically that's 26 char. Right now we need to increment the char that we have found, so I will start making 122 minus c. If this 122 is the ASCII number of letter z, so basically char a is gonna be 25 and char z is gonna be 0. We're just gonna increment it by 1. Right, so after incrementing the anagram, so we need to somehow add it in as a key. So our key is gonna be anagram, and the value is gonna be our array list. But if we don't have an array list, so we're gonna make a new array list, and we need to make it if absent, like if it doesn't exist already. And since, oh, by the way, we have we should have anagram string, not array. So we need to define a string, anagram string. It's gonna be arrays to string, and we're gonna pass the anagram. Right. After this one, now we make sure we have a key here. We have a value specifically for that key, which is anagram string. We're gonna add our new string. Alright, so after adding this string, that's it. Now for our result, we're just gonna add all values in our map, which would be like bat and net and 10 and 8 et. So we're just gonna pass the values here, and that's basically it. So let's run the code and see if it works fine. Right, perfect. Let's run the app and see. Alright, it works fine, and that's basically it. This code runs in big O of n times m, where O, where is, for example, n in our case would be the size of our array of strings, in this one, and m is at most the size of the string. So the biggest length of string is gonna be m. And for this anagram, we're not doing anything much here as a space complexity, because it's fixed size here, and we're using a space complexity of this map. So we have extra space for the map of O of n, since we have a key of each anagram, and for this one it would probably be for each of single strings. So we have O of n time space complexity, and this one, it's kind of forced for us to have this string, but we have also this extra space for just the memory usage of this result, just to be returned in our end of function. So basically we have O of n for the map, and we have also O of m, which is the number of groups we have, which consists of all those kind of variables. So just to make a recap, time complexity is going to be O of n times m, where n is size of array of strings, and m is the largest size of string length. Yes, largest length of strings found. Right, so that's for the time complexity. For the space complexity, it's gonna be O of n plus m, and n, where n is the size of anagrams, signatures, and M is the size of groups. So basically those are our time complexity and space complexity. Hope you benefit something and see you next time.